All right, let's finish chapter 25. The next one is number 20. It's a product decisions under bottlenecked operations. So this mill has 3 grades of metal, 5, 10, and type 20. Financial data for the 3 grades are as follows. Mill's operations require all 3 grades to be melted in a furnace before being formed. The furnace runs 24 hours a day, 7 days a week, and it's production bottleneck. And is a production bottleneck. The furnace hours required per unit of each product type are as follows. 6, 6, 12. The marketing department is considering a new marketing and sales campaign. Which product should be emphasized in the marketing and sales campaign in order to maximize profitability? All right, so the first thing that we'll do is recreate what's in the text there. We'll take that operating statement there, but put it into a contribution margin type of layout. So you got the revenues, we pull that, and then we've got our variable costs, and then we get to our contribution margin. We'll divide that by the number of units, and that's also in the book, 5,000 each, which gives us a unit contribution of $1.80, $4.20, and $6. But what we need to calculate is the unit contribution margin per furnace hour. Per furnace hour. So if our contribution margin is $1.80 for type 5, but it takes 6 hours in the furnace, that's a 30-cent per furnace hour. Do the same thing for type 10, 70 cents. And for type 20, 50 cents. So knowing that, even though the unit contribution is higher for type 20, when we look at the hours in the furnace, type 10 is the one that we want to market because it's the most profitable. And there's 2 problems that we are going to look at. The first one is problem 1A. Differential analysis again. On August 1st, this store considered leasing a building and purchasing the necessary equipment to operate a retail store. Alternatively, the company could use the funds to invest $1 million of 4% treasury bonds that mature in 15 years. The bonds could be purchased at face value. Okay, prepare a differential analysis presenting the proposed operation of the store for 15 years as compared to the treasury bond. So let's just look at the treasury bond here first. Easy. If we invest 4%, it's a 4%, $1 million bond for 15 years, we're looking at 600 grand. No other costs, there you go. Operating the store, and it says here that for the first 6 years, we would get 300 grand. For the first 6 years, 300 grand. It's right there in the reading. The years 7 through 15, 400 grand. You add that up, it's 5.4 million. Cost to operate the store. All right, cost to operate the store. It says here it's yearly cost to operate the store, excluding depreciation, $200,000. Take that times 15, you got 3 million. And then the cost of the equipment less residual value. Cost of the equipment is $1 million. The residual value is 50 grand, so we got 950. So what we're looking at here is, after looking at all the revenues, all the costs to operate, and the cost of the equipment, we're looking at a profit of 1.45 million. So the proposal should be, based on those results, we should operate the retail store. Number 3, if the proposal is accepted, what should the total estimated operating income of the store for the 15 years? Well, so total estimated revenue from operating the store, 5.4 million. Cost to operate the store, 3,950,000. So we're looking at total estimated income from operating the store, 1,450,000. Problem 2A, differential analysis for a machine replacement proposal. This printing company is considering replacing a machine that has been used in its factory for 4 years. Relevant data associated with the operations of the old machine and the new machine, neither of which has an estimated residual value. All right, annual non-manufacturing operating expenses and revenues are not expected to be affected by the purchase of the new machine. Number 1, prepare a differential analysis comparing operations using the present machine with operations using the new machine. The analysis should indicate the total differential profit that would result over the 6-year time frame. So, continue with the old. We don't have nothing to sell. There's no purchase price, but there's some annual manufacturing costs, and that was, as it reads there in the book, $23,600, and we're looking at it for 6 years, $141. So there's our net cost. If we were to go to the new machine, we would sell the old one for $29,700, so that's an inflow. The purchase price, as it's listed there in the book, $119,700, and then it says here estimated annual manufacturing cost would be $6,900 times 6 years, or $41,400. So the difference between continuing with the old or replacing it with a new has a differential effect of $10,200. So going with the new actually is the answer that we should go with. Go with the new. Now, of course, there's all kinds of other factors in there, of which some they list here. Other factors to consider are there any improvements in the quality of the work out by the new machine? That's one thing to consider. What effect does the federal income tax have on this decision? We won't go into taxes here, but that's certainly a factor to think about, no doubt. And what opportunities are available for the use of this $90,000 of funds that are required to purchase this new machine? That concludes our work for Chapter 25. My suggestion is to once again re-review all these exercises that we've done in these videos, making sure you understand what we're looking at, why we want to isolate fixed costs, and why we do that. And that should take care of Chapter 25. Thank you.